Hello and welcome to Database Management Systems. I'm Jovita Christie, and in this video, I'm going to explain to you the select, project, set difference, and union operations in relational algebra. So let's begin. Here you can see the sample database for university. And the first table we have is the instructor table. It contains the ID, name, department, and salary of the instructor. The second table is the course table, which contains the ID, name, and semester and the year in which the course was taught. And the third table is the teachers table. The teachers table contains a relation between instructor and course. So from the teachers table, you can get the information. For example, if you look at the first row shows 1 for instructor ID. You can go back to instructor table and check that 1 is for John from IT department. And then you can further look at the course ID, which is next to John's ID, and you can see that it is 2. So you can conclude by looking at the course table that John taught DBMS in odd 2018. So that's what this database is about. It's a very small one with only 3 tables. Now we're going to begin with the fundamental operations in relational algebra. So these are the operations that are essential for the functioning of relational algebra. And there are 6 such operations. I'll be covering 4 in this video and 2 in the later videos. So the first operation is known as select operation. This is used to apply conditions to select rows. So whenever you want to select some rows and you want to eliminate certain rows based on some condition, then you will be using the select operation. And this is a unary operation. So if you have studied set theory or any kind of mathematical theory, you'd know that there are operators that are unary and operators that are binary. The unary operators are those that require only one operand to work with. For example, if I want to take a modulus of a number, that means give an absolute value of a number, then I only need to pass one number. Like if I give -5, I can get 5. If I give 5, I'll get only 5 as a result. So if I want to find that absolute value, I only need to pass one number. But if I want to add, multiply, subtract, divide, I need to provide 2 numbers. Only then the addition can take place. So select is a unary operator. A binary operator would be one that requires 2 operands. Now, since we are concerned with relational algebra and we're working with tables, not numbers, so when I say unary operator, it requires one table to work with. Now you can see that this is my instructor table, which I had, and I want to get all the employees who are working in the IT department. I want to fetch those by using a query. So I can write my query in this very simple manner. I just need to mention sigma. Sigma is the symbol of select. And then I need to mention depth. Depth is the column on which I want to apply the condition. And the condition is that they should be in IT department. So I just need to write down depth equal to IT. And then in bracket, I can pass the table, which is instructor. So this would show that this condition has to be applied on the instructor table. And this query, as a result, will provide me with all the instructors of IT department. So that's how you can use the sigma operation. And this is the result of it. So you can see there are only 2, which are John and Mary. And remember that this relational algebra that you're studying here is sort of a foundation for many more things to come, like query processing and optimization. And even when you're going to study SQL, this is something that is very helpful because it forms the basic requirement of studying those things. So these queries are not actually implemented, but they are just logical ones. So you just have to keep in mind that when you're writing this, you're not implementing anything. It's just something that is done with logical reasoning on paper. Now, this is what we did earlier. Now, I want to find all employees of IT department with a salary greater than 50,000. So this is another part of the query. Last time I only wanted employees of IT department without any other condition, but this time I would like to have those with a salary greater than 50,000. So I will write my query like this. I simply need to add the second condition, which you can see added right here. I have written salary greater than 50,000, and all this is in the subscript. And in between, I have used the AND operation. So the AND operation allows you to combine two or more conditions together. And for AND, we use the symbol that's used right here. And you can also use OR. So if you want to use OR instead of AND, then you'd be just inverting the symbol that's present here. So this is how you can add more conditions within the same sigma operation. And of course, the result is only one row because John has a salary that is 50,000 but not greater than 50,000. Now, the next fundamental operation is called project, and project is used to select some particular columns to display. And so this is different from select because select is used to select rows, but project is used to project columns. So if you want only certain columns to be present in your table, then you would be using project. And it is also a unary operator, just like select. So in order to work, it needs only one table. Now, this is the query we wrote earlier about getting instructors from IT department with salary greater than 50,000. Now let's add a project operation in it. We're going to find out only names of those employees who are in IT department with salary greater than 50,000. Now remember, we've already done most of this query. The only thing we want now is to eliminate ID, depth, and salary columns because I only want the name. So you can write your query like this. You can see that the query that's inside is nothing but what has been copied from up there. And outside of it, there's another bracket. And then outside the bracket, there is pi I underscore name. This would get me the I underscore name column. Now notice here how this inside inner query is enclosed within these brackets. These brackets help you to create a relation inside whatever is inside the bracket. So whatever you see here, this table that you see here, that table is actually the input for the pi operation. The pi is not actually working on instructor. It is working on this table right here that you are passing as an input. So this query that you see is a query for fetching only names of instructors for which we have used the pi operation. And the pi here stands for project. So as a result of this, this is what you get. The next fundamental operation we are going to see is the union operation. This is a binary operation because it requires two tables instead of one, and it is used to take a union between two tables whereby the tuples are merged and duplicate tuples are removed. And there's a condition for this, which is that both the tables should have same number of attributes and the domains of those attributes must also be the same. So that means the set of permissible values for those attributes must also be the same. You must not try to take a union between a table that contains only names with a table that contains only IDs. That does not make any sense, and both columns are having different domains. Now let's see what union is when we work with numbers. So with numbers, if you have a set A that contains numbers 1 and 2, and set B which contains elements 2 and 3, and if you take a union, that is A union B, then you would get elements 1, 2, and 3, because that's a combination of A and B. Only the 2 is appearing twice. So the 2 is kept only once because the duplicates are removed. Now let's see that with a table. So I'm going to get all the courses that were taught in either ODD 2018 or ODD 2019 or both. This is the query that I have. So in order to perform this, I'm going to use the course table that I have right here. And this is the way you will write your query. You can divide it into two parts. The first part fetches the names of courses that were taught in ODD 2018. So you would write it like this. Within the query, whenever you read a relational algebra query, try to read it from inside the brackets. That's the way it's going to execute. So the innermost bracket is course, and outside that I have sigma, where I'm fetching semester, odd, and year 2019, 2018, which I'm fetching from here. After doing that, I'm again enclosing this into brackets and applying the pi operation and fetching the course names. Now, notice the query that's right here below. It is the same as the query above. The only difference is the year has been changed from 2018 to 19 to fetch courses taught in 2019 of odd semester. And then between these two queries, there is a union operation which has been applied. This union operation will fetch for me the combination of these two. So, let's just see how that works in practice. So the first query is going to fetch DBMS and DS. You can verify that. And the second query is going to fetch for me only DBMS because that's the only one taught in ODD 2019. And then when we take a union of these two, we will get as a result DBMS and DS because those are the only two unique ones. DBMS is repeating, so it will be removed once. Now let's see the next fundamental operation. It is set difference, which is once again binary, and it allows you to eliminate certain values from one table by checking another table. So if there's a value that's available in another table, it will be removed from the current table. That is what you want. Then this is the query, this is the operation that you will use. And this third condition is the same as the condition for union, that you can only perform set difference if you have two tables with same number of columns, and those columns should have the same domains. So let's first understand how this works with numbers. If you have a set A with elements 1 and 2 and set B with elements 2 and 3, then A minus B is going to be equal to 1 because you're subtracting B from A, and within B you have the element 2 which is also present in A. So 2 is eliminated from A, which leaves us with only 1. And if you were to do B minus A, then the element in B which is also present in A will be removed, which means again 2 will be removed from B this time, and we are left with 3. So that's how it works in set theory in mathematics. Now let's apply the same on this course table. The query is kind of similar to what we did earlier. The only difference is here we are trying to get courses that were taught in ODD 2018 but not ODD 2019. So that's the only difference. And in the query itself, you will not notice much difference. You can see both the queries are same. The only operation that is changed between them is the minus operation. There was union earlier and now there is minus. So what it fetches for you are courses that were taught in ODD 2018, which you're fetching here. From this, those that were taught in ODD 2019 are subtracted. So it looks like this. First, you have DBMS and DS, which you have picked. Now from DBMS and DS, we are going to subtract the only course that was taught in ODD 2019, which is DBMS, which as a result leaves us with only DS. So this is how you can apply set difference. And that's it for this video. I'll see you in the next one. Thank you for watching.